All right, here's 2.1, start of chapter 2. Notice the title here, functions and their graphs. We're going back and you'll see a little bit of review of certain types of functions that we've seen, but we'll take more of a graphical approach, right? So far, we've really kind of done some algebra basics in chapter P. And then in chapter 1, kind of in two parts, we really hit lines and quadratics. And we're not necessarily leaving those two types of functions. We're just kind of exploring them more from a graphical perspective. So when you see like, linear equations in two variables, we're doing lines, we already did lines. True, right? And you'll see a little bit of repeated stuff, but you should see the theme starting in this lesson that we'll do some new things with lines, especially graphically, and like writing the equation of a line that we haven't done before. Okay. Start to talk about slope. Number of units line increases or decreases vertically for each unit of horizontal change from left to right. Okay, there's really four cases to look at with slope. I'll give you two of them here. We'll hit two on the next slide. You can have what's called a positive slope, which means that as x is increasing, so is y. And you get a line that looks like that. As you go from left to right, the line's increasing. You can also have what's called a negative slope, which does, as you would expect, just the opposite. But as you go from left to right, the y value is going down, right? And I guess a better way to think about it as the x variable increases, y decreases. Okay, so if you kind of wanted to make the connection here that, a positive slope, that's this case right here. The number of units the line increases for each unit of horizontal change from left to right, because that's really saying, a horizontal change from left to right, that's x increasing. And if y is decreasing as x increases, we'd say it's a negative slope. One quick thing here. Just in terms of like a vocab thing. You would hear me use the term rate of change. Just know that if you see or hear that term, that's the same thing as slope, right? That's like the definition. The slope measures the line's rate of change. All right, we have a formula for slope, which states this. The slope of a line is the difference of the two y coordinates over the difference of the two x coordinates, right? You'd use this formula if you were given 2 points. We give these 2 points really, really fancy names, point number 2 and point number 1. Right, so the subscript there is just the point itself, right? That's the x and the y value for point number 1. X sub 2, y sub 2 is the two coordinates for point number 2. Okay? I'll go here and just do a handful of calculations with slope. Okay? You technically, as long as you keep the order the same, you can call either point number 1 or point number 2, right? Often that question comes up like, hey, which is which? Again, as long as you stay consistent with the order that you subtract them, it doesn't matter, okay? For the sake of simplicity in all four of these slopes, I'm going to say that the second point is point number 2. So according to my formula, I would say 1 minus 0 over 3 minus negative 2, and that would give me a slope of 1/5. On the second one, we'd have 2 minus 2 over 2 minus negative 1. You can find on these, you really just have to be careful with your negative signs. They're easy to get mixed up. All right, so this, well, I said there's really 4 cases of slope to kind of be aware of. And that positive and negative are 2. Here's the third, is you can have a slope of 0. Which if I were to do just a really basic little sketch, would look like that. And that's what we'd call a horizontal line. And if you come across a slope of 0, you know for certain you're dealing with a horizontal line, right? It has a slope of 0. It means it's not increasing, it's not decreasing. Sometimes we call it a constant function. We'll see it again in this lesson. All right, 2 more. Negative 1 minus 4 over 1 minus 0 would be negative 5 over 1, or negative 5, right? There's just a negative slope, so that one would be a decreasing line. And last one, 1 minus 4. All right, so we can't divide by the number 0, okay? So this, technically speaking, we'd have to say is undefined. I'll draw you a picture with this one too. I didn't draw pictures for the others because in the slide before, for like the positive slope and the negative slope, you've got pictures of those, right? So you're probably more familiar with what those tend to look like. Again, a really basic sketch here. That's what we're looking at. And that is the undefined case, is you are always talking about a vertical line. Straight up and down, okay? So just to recap, the four cases with slope I was talking about was positive, negative, 0, and undefined. You've got an example of each one in your notes at this point. All right, let's do a little bit of graphing here. You are going to see that that's the kind of the focal point. M is if you're in slope-intercept form, M is your slope, B is your y-intercept. You work with this form a lot, and you will in Chapter 2, because it's a nice form to graph. Okay? You should know general form, because you may come across it, like in this third example that we're going to graph. It's like, hey, wait a minute, that's in general form. Okay? But if we're going to get serious about graphing, I'm going to zoom in on my graphs here a little bit. You're going to find that we're probably going to switch it to slope-intercept form just because it's a better, easier form. Really, I'm just using those two pieces of information. It's right here, right? The y-intercept is 1. And then the slope tells me to go up 2 and over 1, right? If the slope's a whole number, you can always put it over 1, right? That might be helpful because that kind of relates it back to our definition that it's, for the y variable, is an increase of 2 as x goes up 1. And you just use that slope to put in a bunch of points. And there you go. There's 2x plus 1. Okay? you can see why slope-intercept is nice. That if you can identify what those two numbers are, again, both the slope and the y-intercept, graphing a line is not too terrible to do. It's pretty straightforward. Y equals 2. Okay, so really what we have here is this is 2. The x doesn't show up because it's been multiplied by 0. So this would mean m is 0. And the y-intercept is 2. Okay. Now we saw that case on the slide before, right? If you see a slope of 0, you're talking about a horizontal line, which is what we have here. So really, if that's the case, all we need to know is, all right, it's a horizontal line. Where does it cross the y-axis, right? And we had that in this problem that we saw that, okay, it's right at 2. That's where it'll cross. All right, with x plus y equals 4, the very first thing I would do is subtract x, right? Get it solved for y, and you're in slope-intercept form, and then I can see, all right, m, or my slope is -1, and then my y-intercept is 4. Okay, and once I've got those two pieces, we are good to go. Here's my y-intercept. I'm just putting on a bunch of other points. And there it is, okay? And really, as far as the different types of slope, we covered 3 of them there, right? The one we're missing is the vertical case, which I don't know if I'll have an example. That might actually be a topic we'll need to address in class a little bit as to how I'm not going to, I don't have a graph to talk about here, so I'm not going to address it, but never mind. A very, very last example, we'll get to that today. Because we don't have, like, what equation-wise is going on when we see the case of a vertical line. That's the one we didn't see here. All right, so this piece is a little bit new as well. Let me zoom out here. Not just to graph a linear equation, which we in chapter 1 we did that a little bit. Now we're really diving into the new stuff that we're going to write them, okay? Which we did actually a little bit with quadratics. It's kind of the same thing that we're going to get. We're going to get some information about the line, and then we're going to write an equation about it. It introduces a third form called slope-intercept. It's really kind of a unique form that it's really good for writing the equation of a line, okay? And here's what you need. You need to know the slope. That's not really a big surprise. It seems like any time we're working with a line, we just have to know the slope. We need one other point on the line. By the way, if you're looking at giving your final answer, always y equals mx plus b, right? Just to keep it simple. It's our preferred form. It's our best form, right? We're not going to start with it here because we end up in point slope form. But yeah, we'll put our final answer in slope-intercept form. So here's how it works. Y minus the y-coordinate I know, which is -2, equals the slope times x minus the x-coordinate, which is 1. And then really, it's just a little algebra of just moving stuff around, right? Double negative there is y plus 2. Here we get 3x minus 3. Then I'll take away 2. And get 3x minus 5, right? So that line has got a slope of 3, which isn't really surprising. I already knew that. Problem told me to begin with. It's got a y-intercept of -5, right? And that's kind of the piece by going to slope-intercept form. That was putting my final answer in that form was nice because it did give me that piece of information. It's a good thing to know about a line, and point slope form, like where we started, didn't have that. Okay, didn't tell me that it was at -5. All right, we'll try another one here. Really 3 things to substitute. Slope and then the point that you know. X1 was 1, Y1 was 1. Distribute the -2/3. Now we've got to add 1, right? Which I'm going to say here, we'll call it 1. Over here, I'm going to call it 3/3. Slope is -2/3. Again, I'm doing a little work to get my whoops, I'm gonna go back up here. Doing a little work to get my y-intercept. That should be, hopefully you caught that, right? That needs to be positive because I had a negative times a negative. 2/3 plus 3/3 is 5/3. There's one with fractions, right? Just to show you that you might have to do some algebra with fractions, but that's fine. That's no big deal. Slope of -2/3, y-intercept of 5/3. Nice to see that one that, like, both of those numbers, I think we'd seen it already with the slope, but the y-intercept, we work with a lot of problems where it's a whole number. It doesn't need to be, right? The y-intercept can certainly be a fraction. Slope of 0, y minus 1 equals 0 times x minus 1, right? Well, anything times 0 is just 0, so the x minus 1 is gone, right? And if you look back to the slide before, we saw this, right? That the fact that it just says y equals 1, slope is 0, and I would look at that and say right away, hey, that's a horizontal line, right? There's no x, right? Just y equals 1. It's got a y-intercept of 1, but it's got that slope of 0, okay? Kind of a unique case because it doesn't fit like the form of a line that we're necessarily looking for, that it's got mx plus b. If you want to think about it that way, you certainly can, right? In slope-intercept form, you could write it out like that. It's y equals 0x plus 1. That's why the x doesn't show up. All right, I should have put instructions on these. I didn't and should have. But it's the same, right? We're writing the equation of a line, but the deal here didn't give us a point and a slope, it just gave us 2 points. Big thing, that's enough, okay? If you just give me 2 points and you want the equation of a line that goes through those 2 points, I can get that, okay? Bottom line is you just have to calculate the slope first. Just calculate the slope first, right? Same way we did before. I'm going to go 2 minus 8. Over 5 minus 2 to get negative 6 over 3, which is -2. And from there, we're good. Right? Now that we know the slope is -2, if we go back to like the previous slide and look at how we did those, if I have the slope, I only need one other point. Okay? Well, I have 2 points. So take your pick. Doesn't matter which one you pick. When you go to point slope form, you're going to get the same thing. I'm going to use the second one. I'm going to use the point 5,2. So I will have y minus 2 equals 2x minus 5. And from here, you should find this problem looks just like the previous slide. Distribute the 2. some reason, I have something really against negative signs today, you know? Slope is -2, not +2, okay? Which is why we're getting that +10. And there you go, -2x plus 12. Slope of -2, y-intercept of 12. Let's try two more, just to show you that we'll follow the exact same steps here. 1 minus -3. Over 2 minus -3, that's 4/5. And then I am going to use this point right here, 2, 1. Again, either point works. If you find that one has both points that are positive, I tend to use it just because there's not a negative sign to keep track of, right? So here I'm like 2, 1, -3, -3. Again, it doesn't matter. 2, 1 is the easier point to use, so that's the one I'm going to do. Distribute the 4/5, which would give us -8/5. And we'll add 1, but over here with the whole common denominator thing, 1 really needs to be 5/5. Another one with fractions, which again is just fine. (4/5) x minus 3/5. When we get that to slope-intercept form, typically speaking, we would take a look and see like, hey, could I reduce any of those fractions? But here, no, 4/5 and 3/5. Now, one thing I may show you at some point here, if you were to put your answer in general form, which I don't really care if you do or not, you'd have to get rid of fractions. So this is just kind of a piece that I'll throw. I'm not going to show you an example, at least right now, but I'll get it out there. If you were to ever put an equation in general form, you have to take out the fractions, okay? Which typically means there's some constant, the number it needs to get multiplied by. Sometimes it's a little more obvious than others, but here you'd have to multiply everything by 5, right? Because the y term, the x term, and the constant would, again, all get multiplied by 5 to get rid of fractions, which I'll find a time to give you an example of that. Again, I don't want to do it right now, but that's if you were to put your final answer in general form. Okay, that's kind of I showed you the outline of general form, but didn't mention in it there's no fractions allowed, right? All 3 numbers that show up have to be whole numbers. All right, 1 to go. 6 minus -4 over 1 minus 1 is 10/0. That's an undefined slope. Okay. Here's what you should do. This is kind of a weird case, right? It's not going to work out like these other two where you just get a nice y equals mx plus b, and you can see your y-intercept and your slope, right? Because the slope doesn't have a number when it's vertical because it's not defined, because I end up dividing by 0, okay? What you need to do is look and see what's my x-coordinate, okay? Because if you have a vertical line, the x-coordinate is a constant, okay? It doesn't change. Just think about it. If I were to graph it, right? I know this one goes through, say down here, it has the point 1, -4. Up here, it's 1, 6, right? But every point on that line has the x-coordinate of 1. So it's actually pretty short. That's just the line x equals 1, okay? Again, if you want to think about it kind of like the slope of 0, that it's a special case, you can. Those two you just have to keep clear that if you see like y equals something, that's your horizontal line. And if you see x equals and then just a constant, that is your case where you have your vertical line that is straight up and down. All right, that'll do for graphing and writing lines. More to come on lines in day 2.